Assalamualaikum warahmatullahi wabarakatuh and a very good day. A warm welcome to our respected lecturer, Mr. Muhammad Amir Shah bin Yusof and my fellow peers. Today, the title of our presentation is Farm Mechanization Plan and Cost Computation. Allow me to introduce myself and my co-presenters. My name is Nurzaima binti Zainal. The next presenter is Nur Arif bin Ahmad Saufi, Muhammad Hafizi bin Muhammad Yatim, and Muhammad Shahriza bin Kamaruddin. So in this presentation, we will discuss the strategic mechanization plan and also cost calculation that we have formulated to resolve the critical operational issue at our selected case study location. So to begin, the background of our case study is at Lestari Sawit Estate, and this estate is a mature oil palm plantation with 500 hectare area. Currently, Lestari Sawit Estate is facing a critical manual labour shortage. And this crisis not only disrupt daily operation but also drastically driven up production and also operational expenses. Therefore, the management must execute a strategic plan to overcome this issue. The primary goal of mechanization is to enhance our field capacity, guarantee timely operation and also timeliness, and also and maintain our OER rate at an optimum level. The first delay in this plantation is the first problem is delayed FFB evacuation that will result in if harvested bunches are delayed in reaching the mill, it will trigger a rapid rise in FFA level, which severely degrade the quality of crude palm oil and leads to heavy financial penalties. Then the second problem is delayed herbicide problem. Uncontrolled noxious weeds will quickly colonize the oil palm field that will actively competing with oil palm for vital water, soil nutrient and also applied fertilizer. The mechanization strategy, under this strategy, we focus on mechanizing two primary field operation, that is operation 1, in-field FFB evacuation. The objective is to rapidly collect and transport FFB out from the harvesting area to the collection point as quickly as possible to preserve oil quality. And then the equipment we propose is utilizing a 4-wheel drive mini tractor equipped with hydraulic grabber and also a specialized trailer. Operation 2 will involve herbicide spraying. The objective is to conduct precision weed control to prevent weed outbreak and protect fertilizer investment. And then the equipment we propose is 2-wheel drive utility tractor that is equipped with a tractor mounted boom sprayer. And we hope by combining these two machines, we can drastically reduce our dependency on manual labor while maintaining peak estate productivity. Next, my co-presenter will elaborate on the technical specification of each machine and the operational cost analysis of this operation. The floor is yours.
Assalamualaikum. Thank you, Emma, for the excellent opening. Good day to our lecturer, Muhammad I'm Shah bin Yusuf and my fellow classmate. As Aima mentioned, our group is addressing the massive challenges of several labour shortage and rising production expenses in Malaysian palm oil sector to keep field activities productive and economically sustainable moving forward. Structural farm mechanization is a necessity, not an option. Following up on the foundation, Aima just layout, I will be talking you through our comprehensive farm mechanization strategy for Lestari Sawit Estate for our 500 hectare mesh method oil palm plantation. Specifically, we are going to look closely at two critical field operation in field fresh fruit bunch, FFB, evacuation and herbicide spraying. I will show you exactly how we calculated our machinery capacity, determined the ideal tractor size, and conducted a break-even analysis to prove that owning this fleet is the most cost-effective path forward for the estate. Let me start with our first operation, which is the mechanized collection and transport of fresh fruit bunches. To tackle our labour shortage, we choose a mechanized system using a four-wheel drive mini tractor equipped with a hydraulic grabber and a trailer. This setup allowed the operator to easily pick up the cut fruit bunch from the palm base and move them efficiently to the main roadside collection point. To make this plan work, we apply a several real work field assumption based on the standard plantation practices. First, the tractor will operate at a safe speed of 5 km per hour to navigate the narrow infield path smoothly. Second, we calculated a field efficiency of 70%. This accounts for the time the tractor loses while turning around or positioning the hydraulic grabber to pick up the fruit. The third, when the trailer is fully loaded, it faces a soil draft force of 3 kilonewton ton per meter of weight along the estate path. And finally, we know the engine power is loose through friction, so the actual usable drawbar power is calculated at 86% of the tractor maximum power output. Having the technical parameter logged in allowed us to move directly into our main capacity and power calculation. This dashboard summarizes the capacity, sizing, and investment threshold for our SFB evacuation. The capacity requirement is to cover the entire 500 hectare estate within our strict 20-day monthly working window. We need an effective field capacity EFC of 3.125 hectare per hour. Because the system operates at 70% efficiency, the total theoretical field capacity TFC must be 4.464 hectare per hour. Next is power specification. Based on the trailer weight and the soil draft force, we determined that the tractor requirement a PTO power of 43.26 kilowatts, which is roughly 55 58 horsepower. This given the mini tractor plenty of strength to haul heavy fruit without damaging the engine. The third one, fleet sizing. A standard mini tractor system under this condition realistically manage an EFC of 1.5 hectare per hour by dividing our total requirement capacity by a single machine output. We found that we need exactly 3 mini tractor units to complete the work on time. And four, investment threshold. Financially, each tractor costs RM 43260. After calculation, our annual fixed costs like depreciation, insurance and tax, and comparing them to what a custom outside contractor would charge us RM16 ringgit per hectare. We found our break-even point is 216.87 hectares. Because our estate is 500 hectares, which is way higher than the break-even mark, buying the owning this 3 mini tractor is completely justified. It saves the estate money and guarantees that our fruits get to the mill within the crucial 24 hours window to keep our oil quality high. Next, let us move to our second field operation, weed management. As to the image, to control noxious weed that compete with our oil pump with fertilizer and water. We are replacing a manual knapsack spraying with a two-wheel drive utility tractor mounted with a large boom sprayer. Here is how the agriculture of the spraying system breaks down. The sprayer features a massive 11-meter total working wire made up of 20 chemical nozzle spaces exactly 0.55 meter apart. We set the operating speed at a steady 4 km per hour. Keeping a constant, careful speed is critical here because it ensures precise chemical calibration and prevent the herbicide from drifting away in the wind. Next, the field efficiency is 75%, which leaves a realistic buffer for the operator to refill the water tank, mix chemical, and turn at the end of the row. To run the PTO-driven pump and to carry heavy liquid load, the system needs 1.5 kilowatt of power per meter of wide, since two-wheel tractor working on estate paths have a power efficiency ratio of 61%. The engine requirement total PTO power of 27.05 kilowatts. This adequate to an initial tractor purchase price of Rm 27,050. When we ran the capacity map, we discovered something excellent. One single boom sprayer unit gives us an output of 3.3 hectare per hour. Since the hectare Since the estate only need a minimum of 3.125 hectare per hour to finish on time. Just one a single tractor mounted sprayer unit is enough to manage the entire 500 hectares. Our financial analysis for this sprayer show a break-even point is just 149.80 hectares. Again, because our plantation is 500 hectares, owning the sprayer is far cheaper than hiring an outside contractor. More importantly, it given the estate manager full control over when to spray, stopping weed outbreak before they damage our crop yield. Thank you.
Hello, Assalamualaikum. Now I want to explain about the operational metric. First, our EFC stand at 3.3 hectare per hour, which comfortably exceed our 3.125 hectare per hour for the minimum target. Our TFC is at 4.1 hectare per hour. To achieve a power specification, we require a PTO power of 27.05 kilowatt calculated based on 0.61 roba to engine power ratio suit for firm estate path. Because of high efficiency, our required fleet size is just one single machine. One unit is fully sufficient to complete our entire 500 hectare estate on time. For the financial threshold and conclusion, financially our break-even point is at 149.80 hectare. This is calculated against for our annual fixed cost for about 5,680.50 a custom charge rate of Rm 45 ringgit per hectare and an operating cost of Rm 7 ringgit point 08 hectare. With our estate being 500 hectare, this machine operate well past our break-even threshold, making this mechanization plant both highly efficient and extremely profitable. Okay, now let's jump to the economic justification, the comparison between hiring and ownership. For the Operation 1 FFB evacuation, hiring cost RM 60 ringgit per hectare, where owning dropped our operating cost to just RM 18.11 cent per hectare. For the Operation 2, which is spraying activity, hiring cost RM 45 ringgit per hectare, while owning cost us RM 7.08 per hectare. For the break-even validation, our break-even point are highly achievable. We break even at 217 hectare for FFB evacuation and only 150 hectare for spraying. Given our 500 hectare estate size, we are all past this threshold. For the operation risk and conclusion, timeliness control beyond cost, custom hiring is high risk as we are completely dependent on a contractor schedule. In-house ownership gives us a complete control which protect our oil extraction (OER) and prevent costly weed outbreak. In conclusion, ownership guarantee a significantly lower cost per hectare while securing our critical 24 hours harvesting window. Now I'm highlighting our strategic approach to machinery lifecycle management. This chart demonstrates how cost per unit of use just over 15 years service period, emph- emphasizing the critical threshold at 10 years. The life cycle cost intersect. As you can see, in the earlier years, our accumulated average depreciation dropped steadily. However, this countered by escalating repair and maintenance costs over time. These two cost curves intersect right at 10 years mark. Therefore, our optimal trade window is strictly between 9 to 10 years of service to maximize asset value. For the risk and the conclusion, retaining ownership beyond 10 years is highly discouraged and categorized as economically risky. For the operational threat, surprising this way out of life drastically increased mechanical breakdown during peak harvesting season. This directly threatened our entire mechanization strategy and operational timeline. To secure both cost efficiency and operational reliability, a strict replacement plan at the year's 10 is essential. That's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syariza bin Kamarudin. Okay, we go to the another slide for managerial insight and lesson learned. Okay, thank you to my teammate for walking us through the technical calculation as the final present. I want to step back and look at the bigger picture. What do all these numbers actually mean for us as estate manager? Through this project, our group gained three major insights that change how we view plantation mechanization. Okay, first, the critically of timelines. In our lecture note, field experience, we learned that timelines loss is a massive economic risk. If fresh fruit bunch FFB sit on the ground for too long, free fatty acid FFA levels spike and our quality drop. So choosing a mini tractor is about finding the cheap machine. It is about matching effective field capacity to our critical harvesting window so we can protect our oil extraction rate, OER. Okay, for second, precision is size method, and we have to get it right. We must match our theoretical field capacity and engine power directly to our specific soil and draft condition. If we buy tractor that are too big, we waste money on high annual feed cost. If we buy the too small, we cost operation, bottleneck, and delay in the field. Okay, for third, economy of scale. This is the most exciting takeaway for a manager. By looking at the break-even point, we provide that for a large 500 hectare estate like Lestari Sawit, ownership is absolute. The least cost method, because our land area is big, efficient, absorb to high initial fixed cost, making ownership far better than renting on hiring a contractor. Okay, for next slide, a sustainable and profit driving blueprint. This brings us to our final strategy blueprint for Lestari Sawit Estate. Moving away from manual labor and adapting target mechanization is no longer just an alternative option. It's a baseline operational necessity to survive labor shortage. Here are the final outcome of our mechanized strategy. Okay, number one, protect yield. By owning and running the 4-wheel mini tractor with hydraulic grabber, we guarantee our field application timeline. The fruit get to the mill on time, maximize our OER and protecting estate profit. And number two, resources efficiency. For weight control, we don't need a hard workforce. Just one tractor mount boom sprayer easily manage the entire 500 hectare estate. This disconnect our field productivity from a shrinking manual labor market. Number three, finally, viability. We have planned for the long term by enforcing in discipline 10 years replacement cycle. Replacing our fleet at the 10 years mark ensure we trade them in before repair costs skyrocket and reliability drop, keeping our operation running smoothly and profitably. To conclude our group final report, developing this farm mechanization plan has proven that moving from manual labor to machine drive system gives Lestari Sawit Estate a massive operational advantage and clear financial reward. From economic perspective, both for our operation shop, break-even point will below our actually estate size. The break-even for FAB application is 1217 hectare, and for herbicide spray is only 1,500 hectare. Since our estate in 500 hectare, owning and managing our own fleet is significantly more cost effective than hiring outside contractor. By following this blueprint, matching the right machine size, managing field efficient, and sticking to a straight 10 years replacement cycle, the Lestari Sawit Estate will lower its operating costs, solve its labor dependency, and guarantee long-term profitability in today's global market. With that, we conclude our presentation. Thank you and very much.